Hey everyone, inside every single one of our gadgets, there's this secret war going on, like millions of times a second. It's this constant battle between just raw brute force power and really smart battery-saving efficiency. So yeah, let's dive right in. Okay, so let me start by asking you a question. Picture this. You're looking at a brand new smartphone, and it's boasting a 2.7 gigahertz processor. Then you glance over at your desktop PC, which is maybe a few years old, and it's only running at 2.5 gigahertz. The phone's got to be more powerful, right? Nope, not even a little bit. And that really simple, kind of surprising no is pretty much what this whole thing is about. It turns out the numbers that companies love to show us, well, they're just not giving us the full picture. All right, first things first. Let's just tackle the biggest myth out there head on. For years, we've all been trained to think that more gigahertz equals more power. A higher clock speed means a faster machine. Well, it's time to officially call that one busted.
And look, this isn't just my opinion. It's pretty much a fundamental fact in modern tech. Trying to compare the clock speed of a phone chip to a desktop chip, it's like comparing the engine RPM of a superbike to the engine of a massive freight train. I mean, sure, they're both engines, but they're built for completely different worlds and totally different jobs.
And that's really the key here. These two types of processors are designed with completely opposite goals in mind. Your desktop CPU, it's all about raw performance. It's plugged into the wall, it's got beefy fans to keep it cool, it can afford to get hot and just guzzle power. But your phone's processor? It's crammed into this tiny little sealed box with no fans, and its number one job, above all else, is to sip power. It has to be efficient enough to make your battery last all day. So you might be wondering, how did we even get here? How did we end up with these two totally separate families of processors? Well, it all comes down to two competing design philosophies that have basically shaped the entire tech industry. You can almost think of them as the two main characters in our little tech story. So in one corner, we have something called RISC. That stands for Reduced Instruction Set Computing. Now, this is the playbook that ARM uses, and their designs are in pretty much every single smartphone out there. The whole idea is to use a really small, simple set of instructions. Each one doesn't do a whole lot on its own, but the chip can just blaze through them super, super fast and using barely any power. And then, in the other corner, you've got CISC, which is Complex Instruction Set Computing. This is the world of Intel and AMD, the chips in most of our PCs. With CISC, the processor has this massive vocabulary of really complex commands. Just one single instruction can kick off a whole chain of operations. It's incredibly powerful, but you need a much bigger, more complicated, and definitely more power-hungry chip to make it happen. And it's really easy to see how these two different approaches have shaped the market we have today. ARM, with its efficient RISC designs, licenses its tech to pretty much everyone. We're talking Apple, Qualcomm, Samsung. And that's created this huge, diverse world of mobile devices. On the flip side, you've got Intel and AMD making their own powerful CISC-based x86 chips, and they absolutely dominate the world of PCs and data centers. It's really two separate universes, all born from these two different ways of thinking. Okay, so let's zoom in a bit. Let's get back to your smartphone. How does it manage to use these super efficient designs, but still give you that burst of incredible performance right when you need it? Well, a big part of the magic is something called a system on a chip, or SoC for short. Instead of having a separate chip for the processor, another for graphics, another for memory, and so on, a mobile SoC literally crams the whole computer onto one tiny little piece of silicon. And the reason for this is all about saving two things: space and, you guessed it, power. But wait, there's an even cleverer trick hiding inside that SoC. It's a technology from ARM called Big.Little. And what it does is it pairs two different kinds of processor cores together. So when you're doing something simple like texting or just listening to music, your phone is using these tiny, super high-efficiency little cores. But the moment you launch a heavy-duty game, boom, it instantly and seamlessly switches over to the powerful big cores for maximum performance. You really get the best of both worlds. There is a catch, though. There's always a catch, right? This chart here shows what happens when you're gaming for a while. You can see the performance starts off super high, absolutely flying. But as that little chip gets hotter and hotter inside that sealed phone, it has to protect itself. It has to slow down to cool off. This is called thermal throttling, and it's the real-world consequence, the physical limit of that power versus performance trade-off we've been talking about. And that brings us right to the front lines of this whole battle. Because to get more performance and, at the same time, more efficiency, there's really only one way to go: smaller. I mean, way, way smaller. 2 nanometers. Let that sink in for a second.
A nanometer is 1/1000th of a meter. Just to give you some context, a single strand of your hair is about 80,000 nanometers thick. That's the mind-bogglingly tiny scale we're dealing with here.
Yeah, this whole war we're talking about, it's being fought at the atomic scale. And the goal is actually pretty simple on paper. Just shrink the transistors. Those are the tiny on-off switches that make a processor work. If you can make them smaller, you can pack way more of them onto a single chip. And more transistors means you get more power and better efficiency. And this right here, this is the absolute bleeding edge of technology. You've got the two heavyweights, Intel and TSMC, going toe-to-toe. Just look at that power delivery row for a second. Intel is rolling out this wild new tech called PowerVia, where they're feeding power to the chip from the backside. That's a totally different approach than what TSMC is doing. It's these kinds of crazy innovations that turn this into a multi-billion-dollar race that's basically going to define our tech for the next 10 years.
Okay, so for this last part, let's just zoom out a little. Because as fascinating as this war between chip designs is, the truth is the fundamental nature of computing itself is starting to shift.
Here's the thing. For the really big, exciting stuff that's coming next, the CPU, well, it might not be the star of the show anymore. And that means this whole debate between ARM and x86, it might be getting overshadowed by something even bigger. Just think about AI and machine learning. All that stuff runs primarily on GPUs because they're perfect for doing thousands of simple things all at the same time. Even in the world's biggest supercomputers, the CPU's main job is becoming less about thinking and more about just feeding data to these gigantic GPUs as fast as it possibly can. The whole center of gravity in the computing world is shifting.
And that leaves us with one last big question to think about. We've spent all this time talking about the war between RISC and CISC, between ARM and Intel, but what if the future isn't about one winner? What if it's about a whole ecosystem of specialized chips, CPUs, GPUs, AI accelerators, all working together? If that's the case, have we been watching the wrong fight this whole time? Maybe the war for single, dominant chip design is already over, and the age of collaboration is just getting started. Thanks so much for joining me.